Isomers are compounds that have the same molecular formula, meaning they contain the same types and numbers of atoms, but they differ in their structural arrangement or spatial orientation. In other words, isomers have the same ingredients, but arranged in different ways. There are two main types of isomers, structural isomers and stereoisomer. Structural isomers, or constitutional isomers. Structural isomers have different arrangements of atoms, resulting in distinct connectivity of atoms in their molecular structures. They can be further categorized into A. Chain isomers. These isomers have different arrangements of the carbon skeleton. For example, consider butane and isobutane. Both have the molecular formula C4H10, but their carbon skeletons are arranged differently. B. Position isomers. In position isomers, the functional group or substituent is attached to different carbon atoms within the same carbon skeleton. An example is the compounds 1-propanol and 2-propanol, both with the formula C3H80. Functional group isomers. These isomers have different functional groups, but the same molecular formula. For instance, ethanol, C2H5OH, and dimethyl ether, CH3OCH3, are functional group isomers. D. Ring isomers. These isomers involve different arrangements of atoms in cyclic structures. D. Ring isomers. These isomers involve different arrangements of atoms in cyclic structures. Cyclohexane and methylcyclopentane are examples of ring isomers with the formula C6H12. Stereoisomers, it have the same atomic connectivity but are in the spatial arrangement of atoms. They arise due to the restricted rotation around double bonds or around specific atoms. Stereoisomers can be further divided into geometric, cistrans, isomers. B. Optical isomers, enantiomers. A. Geometric, cistrans, isomers. These isomers occur in compounds with restricted rotation around a double bond. If two similar substituents are on the same side of the double bond, it's called cis. If they're on opposite sides, it's called trans isomers. B. Optical isomers, enantiomers. These isomers are non-superimposable mirror images of each other. They have a special type of stereocenter called a chiral center. Enantiomers have identical physical properties, but often exhibit different chemical behavior, particularly in chiral environments. Isomers are crucial in understanding the diversity of organic compounds and their behavior. They can have different properties, reactivities, and biological activities despite having the same molecular formula. For detailed lecture check playlist in the channel, you will get it very helping.